Hi guys, so welcome back again. My name is Sehdev, and so we've been trying to model an insurance product in this short coursework. So till now, we have been able to finish off with expenses, premiums, and some basic assumptions. Again, guys, so if you've got any issues related to data types, tuples, strings, and data frames, dictionaries, or modules, functions, and libraries like NumPy and Panda. I hope you guys went through Kamal's course on Actually Sense for Python for Actuaries, and he's got a very elaborated course on SQL for Actuaries as well. So even if you're not an actuary, you can still go through it and you can understand a lot of things from there. So let's get started with commissions, then we'll move on to maturity benefit, and we'll slowly move on to loyalty bonus, then we'll join the bonus, and we'll move on to decrements and further on. Right. So let's get started. Again, the commissions need to be paid to different brokers. Brokers come into different sales channel where through which companies, insurance companies acquire policy holders, right? So so basically, what do we need to do here? We need to set initial commission, right? We need to set renewal commission, and we also need to set total commission, right? Yeah, so that's what we need to set here. So let's get started. So initial commission should be paid for the first year. Renewal commission should be paid for any years after the first year, and the total commission would obviously be the sum of them, right? So so we have our product prod 1. So let's just set it at 0 for starters. Now we have got a column, but then all the values are 0, right? So as you know, now we've created a column, but we need to set the value now. So what have we been using when we're trying to set something? We'll be using lock, and lock is one of the most used function from pandas. So you guys will use it a lot when you're trying to do any data manipulation or any data analytics kind of work, right? So what do we need? We need policy here to be less than 1, and yeah, it's just the policy should be less than 1. Then we've got our initial com as let's say we're paying 500 to these brokers. Right, guys, this is an invalid syntax. Now why is that an invalid syntax? We've used log before, so let's just scroll and realize that what is different in this log. So our condition is fine. Now it says there's an error near this place. So what's wrong with these quotes, right? So we're missing a comma here, right? So yeah, you know I am doing all of these basic things to make sure that you guys realize that you can just scroll back to your codes, and you guys can just go to internet and find out where you're actually lacking. So these are all very small errors, and Python is a language, or Jupyter is a workbook or a notebook where you will literally find infinite sources, and when I say infinite, I actually mean it, to fix your problems. Yeah, so we're good with this, right? So now what we're going to do, we're going to be setting our renewal commission. Right, guys, always maintain basic hygiene and code hygiene when you're coding. If you're following a certain type of naming convention, just keep following that, right? So let's just set rencom as 0. Then we're going to use lock again, right? So we can use npwhere. Npwhere is basically numpy, and lock is basically pandas, but I prefer lock because it's just like easier and it's cleaner. So what do we need? We need to set renewal commission where the policy year is greater than 0, and these commissions should be paid till maturity, right? Not after that. So maturity age. Now we're setting, what do we have? We have ren com, and we're setting it as, right, we've not decided what we're setting it as, right? So our expenses are 1% of the premium, so let's just take this as 0.3% of our premiums. No big deal. We're a rich company, we can afford to pay some money, right? And yeah, I think it's good hygiene. Also, we can always just copy this, right? We can just copy this and we can check if this is working fine or not. Yeah, so it is right. So we have this going on, so yeah, this is working fine. So now what do we need? We need the third is setting total commissions. So let's just set total commissions as a sum of, guys, the idea is to make you understand that if you were on Excel, you would just do an equal to and then select those columns and just sum it up. Or probably if you have a better hygiene, you would have named these columns in your Excel as named ranges, and you would just call those named ranges, right? So what I am trying to tell you here is that it's actually that simple. I mean, and probably it's much more simpler because when you're dealing with large data sets, this doesn't crash and it's error free. If there is an error, you can just scroll, or you can just go to the internet and you can find 10,000 sources. I mean, you can find infinite sources also. So yeah. So yep. So we have total commissions. It's showing as 500 here because it's taking initial commission, and then yeah. So yeah, that's fine. So our commissions are done, right? And now we are going to be moving to our benefits. So yeah, the type of benefits that exist are death, maturity, surrender, survival. There is a guaranteed GSV and SSV, that's guaranteed surrender benefit, and a special surrender benefit, right? And then all of these benefits are basically outflows for a company. So one of the key factors for any benefit is the sum assured, right? So let's set it as 3 CR, right? Okay, I always use commas because I still get confused. So yeah, you can do this. That's my secret hack to know what is 3 CR and what's probably 30 million or something. So yeah, you can use this. And what do we have? Fraud one. Maturity benefit. Let's set it as, well, let's just set it as 0. Right now the idea is, okay, so we can have a lot of conditions here. We can set maturity benefit as 10 times the sum assured, or 20 times the sum assured, or sum assured plus the accrued premiums. So here we're going to keep it simple, and I will leave it up to you guys to let your imagination run wild and probably create something that's a good factor. You can look up a lot of insurance products online and model their maturity benefit as an exercise. So let's just set maturity benefit right now. So when is maturity benefit paid out? When the age of the policyholder equals to the maturity age, right? And it doesn't get paid out in the first month. The premiums come in the first month or the beginning of the month or the beginning of the year, and the benefits are always paid out at the end of the month or the end of the year, right? So we have our month equal to 12, right? Then we're setting what? We're setting our mat ben, and here we're just making it equal to our sum assured. Oh, yeah, so basically Control Z works. So if you made some error in the cell, you can always just do Control Z. So yeah, paste. So yeah, this is fine. So basically we've been able to set our maturity benefit also. So now if I need to actually find out if this has been set, because if I'm looking at my product one, I will not be able to find out, right? Because this is getting truncated. We can either, yeah, so this is not going to work. So let's just do one thing. Let's copy this entire condition and see if there is a place, or in fact let's just copy this part, right? Let's just see what exactly is happening when our current age is equal to the maturity age. Alright, so when our current age is equal to the maturity age, we have 12 months, right? And yep, so in the first 11 months it's not being paid. The sum assured is obviously 3 CR, and that's like, setting a value, but the benefit that actually being paid is at the end of the months. And yeah, that's how you can call any data frame or any set of piece. Just create a condition and you will be able to call it. So let's move on to loyalty bonus now. Right, so to make it more exciting, what I have done is to create a separate data frame and then join that entire data frame into our old data frame. Now, when we're joining any two data frames, what we basically need is the same column with the same data type. And also there's one thing that we need to learn is that you don't always have to code each and everything. So there are times when you can actually take something from your previous piece of code, or the codes that have already been made or are available, because we're all working in consultancies, and we have something available, or there's a lot of things available online, or probably there was a senior in the company who probably built something. So I'm just trying to teach you on how to use the pieces that you have already created or you have available with you. So what I have done is I have taken my initial piece of code and I have pasted it under loyalty bonus. Now what I'm going to do is I'm going to create a new data frame, probably name it loybon. Right, I'm going to just copy it, paste it here. I mean, I could type this, it's really not going to take a lot of time, but I'm just trying to tell you how it's actually going to help you when you have bigger data frames and bigger problems. So yeah, let's just okay, so we're good with this. We've changed all prod one with loybon. So let's, as you can see, the last run cell was 52 and this is still showing 345, right? Because we've not run it. We've basically copied it from our third run cell. So now it's 53. Yeah, that's an empty data frame that we've created. Like we created a prod one. So we have serial number just how we did in prod 1, right? Now we have a list that's L, that's 1 to 12, and we're setting month equal to L, how we did earlier. Now we're going to create a small loop where what we're doing is that we are taking the year list and we're adding 1 2 3 4 onto it. So what we're doing is basically we are doing it in loop so that our year is able to get repeated for every 12 months, right? Oh, perfect. It's absolutely perfect. So we have been able to now create a loyalty bonus data frame. Now what do we need? We actually need loyalty bonus in it, right? We just have a data frame now. So let's do a loyalty bonus rate. So let's make sure that we are paying probably 5% of the sum assured as the loyalty bonus, right? So the thing with loyalty bonus is that it is only paid if the policy holder is loyal. That means if the policy holder continues to pay the premium. It's like making sure that the policy holder is hooked to your product and is continuously attached, because the policy holder might have a perception that if he or she continues to pay the premium, they will get a loyalty bonus, right? It's just a way to keep your customers attached. Okay. Now, loyalty bonus is a bonus that's usually paid in a interval of years, right? In an interval. So, what we're going to do is we're going to create a condition where loyalty bonus is paid in every 5 years. Now, how do we find out if it is paid in every 5 years? There are multiple ways of doing it. One way could be taking a step in years. So basically, first would be paid in 2022, then 27, then 32, 37, and so on. Or the other way is that we could use the serial numbers, and 5 years is 5 into 12 is like 60. So basically take a mod of 60, and whenever the mod is 0, so basically the remainder is 0, and then the loyalty bonus rate is being assigned, right? So so actually, let's just set it as 0 for now, and now create a condition where we are assigning the loyalty bonus rate. So I think we need lock. Right, to calculate mod we need this percentage and 0. All right. So yeah, now let's just check whether a rate is being applied correctly or not. Yup. So if we see that it's always on like 59, 119, 179. So basically these index created by Jupyter Notebook itself. But if we look, that 0 is 1, 1 is 2, so 59 is probably 60. So it's on the 5th year. So yep, that's absolutely fine, and I think our loyalty bonus is working fine. Now it's 0.05. So basically it's 5%, but 5% of what? It is 5% of the sum assured, right? And we do not have sum assured in this. So either we can add sum assured onto this, or we can just join this table or this data frame that we have created, that's loybon, to our main data frame. Now joining is something that can be done in multiple ways. Some people use dot join. For that they need to set index, they need to create common index values. Probably here they can set index on serial number, month, year. Although I wouldn't advise setting index on year because it's not a unique value, it's being repeated 12 times over and over again. So what I am going to use and what I personally prefer, because one of my colleagues who used to teach me Python really suggested that it's good to use merge because there are a lot of confusions that get omitted. So let's use merge. It's a pandas function, prod1 dot. So it's data frame dot merge. And okay, so what are we merging? We are merging our data frame loibon. How are we merging it? It's just like joins, right? So what kind of join do you want? I want a left join where I want everything from prod1 and these 3 4 columns from loibon. On, now on is like what is the column that you're using to merge. So this needs to be the common column, right? So now we have serial number, month, year, but I'm just going to use serial number. And I can use multiple columns, but I'm just going to use serial number here because it's unique. Right, so now let's check. So basically let's just scroll up. So this had 3 columns and our older database had 20 columns. So if you're joining, then we should have not 23 but 22 because serial number remains column. Month and year also is common, but we're not using them as as columns we're joining on, right? So we need to be cautious. So let's see what do we have here now. And yep, so we have 23. Okay, so we have serial number. As you see, this month and year has turned into month underscore x and month year underscore x, and this new one has turned into month underscore y and year underscore y. So Python in itself, because the names were repeated, it is smart enough to change the names, and the loyalty bonus rate is also attached. So now we can create a column called loyalty bonus amount where we can actually multiply the loyalty bonus rate with our sum assured. So let's do that. Loibon amount, and as usual we set it at 0. Now let's use our condition prod1 dot lock. Now what is our condition? Our loyalty bonus will be paid when policy holder is less than the current age is less than the maturity age, right? That's the idea. And that is when we're going to pay loyalty bonus amount, and it should be loyalty bonus rate multiplied with the sum assured, right? So let's check if it is working for us or not. So do we have our loibon amount here? Yes, we do, but we obviously cannot see. So one way to see is check the unique values, and the other way is to check the sum, right? So the loibon amount dot unique. So yes, it is actually 5% of the 3CR value that we're taking. And let's check whether it has been applied to all the years properly or not. Dot sum. Of course, because it is not sun, it is sum. Yeah. Right, so it is actually being applied. So that is one way where we can take any sort of bonuses. We can create a table of different bonus rates as per different months. So we can have probably 5% bonus in the first year, 10% in the second year, 30% in the third year, or we can have 5% for first 10, 20% for the other 10 years, and 21st year to 30th year we can have 30% bonus. So we can create multiple tables, and then we can easily join them on common columns, and those common columns could be, something that's unique, something that doesn't create an overlap and doesn't confuse Python. Otherwise we're going to get a lot of nan value that is not a number, right? And that is why I avoided the months and the years, because they had a lot of repetitive values in those, whereas the serial number was just unique, right? So it's just 1 to 1440. So yep, here we have been able to figure out how to finish off maturity benefit, loyalty bonus. Next we're going to do total bonus, decrement, discounting, and reserve. So yeah, stay tuned guys, and if you've got any doubts just reach out to me. Thank you.